Well, hello. Today we're going to be talking about decimals. Now, decimals really just part of a whole, and we already did that in the past when we talked about fractions. I really like fractions, but not everyone likes fractions. Decimals really are just fractions, but working only in powers of 10. So we have the dec part of that, and that's going to refer back to 10. So when we're working with decimals, we're really just kind of working with fractions that are all related to tens or powers of tens. Now, we can break numbers up. We know that in a whole could be way more than this, but we're going to break them up into tenths, hundredths, and thousandths. So in this case, a whole is made up of 10 flats. You could see like this is like one layer, and you could see that we could count. There's 10 layers all the way back here. And then each flat is made up of 10 rods. You could count this and say, look, here's a rod, there's a rod, there's a rod, and so on. And each rod is made up of 10 units. So we like these powers of tens. They just work really well together. All right, how many flats are in a whole? Well, we just talked about that. There's 10 flats in a whole. And so therefore, one flat equals 1/10 of a whole. Okay. How many rods are in a whole? Well, this one isn't quite as easy to visualize, but with a little bit of multiplication, we figure it out simply enough. We know that there's 10 rods in each flat. Each one of these flats has 10 rods in it, and we know that there's 10 flats in the whole. So therefore, there must be 10 times 10, or in other words, 100 rods in a whole. Therefore, one rod is 1/100th of a whole. And in the units, same idea as before. So we've got the 10 units in a rod, we've got the 10 rods in the flat, and we've got the 10 flats in the whole. And so ultimately, that means that we are going to have, as far as how many units are in the whole, 10 times 10 times 10 means that in this case there's 1,000 units in the whole, or in other words, one unit is 1/1000th of a whole. Okay. Now, when we talk about the whole, that's just going to be our unit. Okay, and we can extend this idea to much larger numbers, and ultimately this is just a little diagram to kind of show you that whenever we talk about making numbers bigger, we can start out with this 1 right here, right? And then if we have 10 of those, then that would make the tens column. And if we have 10 of those tens, right, a flat, that would be our hundreds column. And then if we put 10 of those flats together, it makes this one big cube. That would be 1,000. We just said there would be 1,000 of these little squares would be right here. But if we take this and we squash it down to something really, really tiny, like ultimately this block and this block are the same. There would be 1,000 tiny little yellow cubes in this one little green one. And then we can again just repeat the process. 10 of these little green ones make a flat, a rod, 10 rods make a flat, 10 flats make a whole. And then we would say, oh, if you take all of these and you squish it down, we're going to make one big red one. So this is a way that we can work with place value. Now, it also goes back the other way, that we can make things much smaller as well. So just because we only have tenths, hundredths, and thousandths doesn't mean that it has to stop there. Okay, but this is what we're working with for now. So our ones, this will be like our cubes. Our tenths, that's going to be our flats. Our hundredths is going to be our rods. And then our thousandths, that's going to be our units. Okay. All right. So with that in mind, let's start looking over a few numbers here. Okay. If we have a decimal like 0.252, and keep in mind, this of course is less than 1, right? Because it's a 0 point. 252. Okay. You could almost think of this if we didn't have this here. This would be like a quarter, right? So it's worth 25 cents or something, you know? Okay, so when we go to draw this out, this is the flats, the rods, the units, right? The flats, 0. The rods, 4. The units, well, there isn't any. And if there's no units, then we'll just put 0 here. So ultimately, if I were going to make this as a picture, I would just have 4 rods and then be done. Okay. All right, point 4. Remember, here's our flats. So we have 4 of them. Then afterwards, we have the rods. There's not any. And then there's also no units as well. So this is just 4 flats. 1, 2, 3, 4. Done. Point 326. Remember, we have our flats, rods, units. So 3 flats, 2 rods, 6 units. 3 flats, 2 rods, and then 6 units. There we go. You could draw tiny little boxes, but I wouldn't recommend it. Drawing a little box starts to make you wonder if it's a little box or a big box, especially when you get sloppy. Okay, when we look at this, 1 flat, 2 rod, 3 units, well, that's 1 flat, 2 rods, 3 units, and then that would just be point 1, 2, 3, because it goes flats, rods, units, tenths, hundredths, thousandths, right? 5 flats, 0 rods, 7 units would be 0.507. That's 5 flats, 0 rods, 7 units. There we go. When we look over at this next picture and see what this represents, you can see I don't have any flats, but I do have let's see, 1, 2, 3, 4, 5, 6 rods, and then I've got 7 units. So that means that this is going to be 0.067. Okay, this next one's a little easier to count. There's 2 flats, 0 rods, 7 units, or 0.207. All right, so here we have some fractions. A lot of people don't like fractions so much. I happen to like them a lot. But we're going to do a lot of this without so much fractions. So let's get, you can kind of read this on your own and kind of see that, but we're going to go down and kind of demonstrate what's happening here. And it's just that idea of regrouping things, okay? That's all we're doing is we're regrouping things. So here, if I've got this 1 flat, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of these units, I can actually group some of them together. I can group them by tens. That's not 10. There we go. And then we'll just grab this, make a little fix here. There. Now we have a group of tens. See, these 10 units, they go together to make this 1 rod. Now I could write this as 1 flat, 1 rod, 3 units, or tenths, hundredths, thousandths, 0.113. Okay. So let's look over at this one, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's group all these together. This is kind of hard on the computer here. All those together, those are gonna we're not going to write those as 10 different rods. We'll write that as 1 actual flat. So we've got 1 flat, 2 rods, and 5 units. Tenths, hundredths, thousandths makes this 0.125. Okay. Let's look over here. This one's kind of an interesting one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ah, I can't group those. Rats. Okay, well, let's move over and look at our units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, all these units go together to make one rod. And then I can say, now I have actually 10 rods, so I can put all 10 of these rods together. Like that. And now I just have one flat. That's all. Done. Remember, the flats are the tenths, so it's 0.1. And you could even think of this like 0.100. Like, that's actually the same, right? We have 0 rods and 0 flats left over. So 0.100 is the same as 0.1. Now, when you really get into certain things, when you start talking about precision or significant figures and stuff, like it gets a little complicated. But for just pure math purposes and what we're talking about, we can just say 0.1 is equal to 0.100. Okay? All right. Let's keep looking here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I'll group those. Let's put those together like that. And then the thing is that actually is, well, let's change the color on that. There we go. The reason that I changed the color on that is because we actually have 10 flats. And those 10 flats are going to make one big cube. Okay, so we have one cube. So I've got one cube. There we go. And then we still have one flat. Right? We've got 2 rods. And then 3 units. Felt like being colorful there. So remember, the decimal is actually going to go right here because we have flats, rods, units. And so this is just going to be, after the decimal is 1, 2, 3. And before the decimal, we'd say how many whole do we have? How many holes do we have? We've got just one. So 1.123. Okay. Let's go ahead and take a look here. We can draw. We're just going to be doing some more decomposition, is what we've been doing here. This is important for whenever we're subtracting. The idea of borrowing and being able to break something up into different parts. Again, we've already done this with fractions, but maybe this makes perfect sense to you, and you can just kind of skip over this section and go on to the next section. That's fine. I just want to make sure that we do take a minute and to recognize what's happening so you can see it visually. Maybe no one's ever done that for you before, or you've never really thought about what it means to be a tenth and how that relates to hundredths. Okay, so using only rods and units. Well, I've got my 5 units here. That's easy enough. I can put that on there. And then rods. I got to think about how many rods are here. Well, there's 10 of them. There's 10 rods. There we go. So here's a way to write 0.105 with our visual representation. Notice that it's kind of like we have point, and then we have 1 flat, 0 rods, I just kind of left it blank, and 5 units. Well, now, coming over here, you could almost think of it like I have 0 flats, 10 rods, and 5 units. These two are equivalent. Okay. Let's look down here. I've got 3, 2, 4. So I've got 1, 2, 3, and then we have 2 rods, and then 4 units. Now we can use only flats and units. So if I'm thinking about like my 3 places, almost like place values, it's still okay to have these 3 squares here, the 3 flats, 1, 2, 3, because it said flats are okay. But it says that I can only use flats and units, so that means I've got to leave this blank. I'm going to change both of these rods. I've got to change these into units. So each one of these is worth 10 units. So I'll come down here, 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. And that's the first rod. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I also still had my original 4. There we go. Done. 1.02 only using flats and units. One whole amount, right? That's our cube. And then, ooh, almost think of this as like nothing here and nothing here and all the way down to here, and we just have our 2 units. So if I can only use flats and units, right? I'm just going to put these in here because this is what makes sense to me, and hopefully you can start associating these with their place value. 10 flats make up one whole unit. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. So we have 10 flats. We have nothing left over here in the rods, and then units we just have 2. Done. Now, throughout this lesson, I've been saying things like tenths, hundredths, and thousandths because I think you're probably already a little familiar with that. And we saw how the unit place that we were looking at was actually 1/1000th of the whole. So we've been able to say those kinds of words. But let's really break down what a decimal looks like and how to say it. If I were to say, how would you pronounce this? A lot of people would probably say, oh, 0.532. A lot of people would probably say something like that. But if we actually want to call it by its real name, we have to understand what's happening. And we've already set everything up that you can see that. See, right here we have our 5 flats, in other words, 5 times a tenth. And here we have our 3 rods, or 3 times 100th. Remember we said a rod was 1/100th of the whole. And here we have our 2 units, which we said was 1,000th. So if we have 2 of them, that would be 2,000ths. Now you wouldn't say, oh, this is 5 tenths, 300ths, 2,000ths. Although that would be not inaccurate, it's just not the way that we say these. So if you look at trying to add these up, we said 5 times a tenth, 3 times 100th, 2 times 1,000th. If we look at trying to add those, we actually are going to get common denominators, which we've done in the past. And that would actually just be 1,000. So we could multiply this by 100 over 100, this one by 10 over 10, and this one by 1 over 1, or by nothing. Now, maybe you don't like fractions, and you're like, whoa, 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 let's not talk about fractions. We're talking about decimals, not fractions. Okay, we can do this. So here I have 5 tenths. Remember, that's the same thing as 5 flats. So if I've got these 5 flats, and I'm not going to draw this very good here, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What we would get is we would have 100 units right here. This is 100 units. And so is this one. This one's 100 units. This one's 100 units. This one's 100 units. 100 units. That means that these 5 flats actually become 500. This part right here becomes 500 units. And this one represents our rods, right? So we have one long rod here. Well, we'd have 3 of those. And if we were to write those in units, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that makes 10. 1, 2, 3, 4, 5, 6, 7. There we go. Probably. And so that means we actually end up with 30 of those. These 3 rods turns into 30 units. These 5 flats turned into 500 units, and then we still have our 2 units. Now, we just did that without common denominators. We just changed everything into units. And then we've got 500 plus 30 plus 2 is 532. And if we're working in our units, remember those are 1,000th. So 532 thousandths. Now that's actually how this is read out loud, right? 532 thousandths is how you would read that. You see, what you do Well, let's look at this next example here, and then we'll kind of make sure, see if you can understand. So how many flats, rods, and units are used in this decimal? Well, we have 1 flat, 2 rods, 3 units, and so essentially we have 0 ones, 1/10, 200th, 3 thousandths. The decimal in expanded form would say 1/10 plus 2 hundredths plus 3 thousandths, like that. Okay. And then when we add all those fractions together, you get your common denominators, or you just think about how much is that a flat worth? Well, it's worth 100 units. And how much is that rod worth? Each rod is worth 10, and there was 2 of them. So that would be 20 units. And then the last one, there was only 3 units. So ultimately, this is 123 thousandths. 100 and 20, you know what? 100, let's just do this. 123, whoops, changed colors. 23 thousandths. Okay, that makes a big difference to put that THS on there. That's a big difference. That means that we're going to be working in fractions. Because if we didn't put that on there and I just had 123, 23,000, if I just stopped there, 123,000 is this much. That's how much money I would like to have right now. Right? 123,000. So much money if I was talking about dollars, I guess. But 123 thousandths is this. And if we were to change that into money, it would be a little over 12 cents. There's a big difference. This THS right here makes a big difference. Please pay close attention to it. Now, as far as naming these decimals, you don't actually have to go through and change everything into a fraction in order to name them well. In fact, all you got to do is look at the smallest decimal that you have. In this case, we are looking all the way down here in the thousandths category. And then we take all these decimals together. I see 516. So 516 thousandths. If I was to write this out, I would first do the whole number part, 372. Then we put the and right here, and that's actually why I took the and out from up there whenever I first started writing it. Okay? And then 516 thousandths. So we've got our 2 parts, and the decimal essentially is going to be replaced with the word and. 372 and 516, whatever this last label is for the smallest one, that's your name. That's your label. So this one, if we look at 4 and 23 hundredths, well, here's 4. And then we also have the and, that's the decimal, so 4 and 23 hundredths. Oops. Or in other words, 4.23. Okay. Let's do just a few more examples, and then we're going to wrap it up here in the next couple minutes. Okay. So if I was looking at something like this, of course, you can look at this example on your own, pause and check it out, or just check your notes. That's fine too. Okay. So if I've got 2 flats, right? 2 flats, 4 rods, 0 units. I have 0 ones. I have 2 tenths. I have 4 hundredths, and I have 0 thousandths. Now, for the most part, I told you before, like these are the same. If I were to write this as, 0.240 versus 0.24, like they are the same for what we're doing, but it's good practice that if you don't have the 0 and we don't have anything here to start with, we won't put the 0. It does imply a level of precision as far as how you're measuring by. And so since we don't have anything there, I'm actually just going to leave it blank. Okay? So when we look at this, we've got 2/10, 4/100, 0 thousandths. So we won't need that. And then what we're going to do is we're going to add those up. 24 100ths. Okay? So this is 24 hundredths. There we go. Notice that the most accurate decimal that we have is in the hundredths category, and that's why we have the name hundredths. Something like this one, if I have 3 flats, remember flat is in the tenths, 0 rods, and 5 units. I do need to put this 0 here. We only just don't put the zeros on the very end of this. They're important in the middle. Okay? So keep that in mind. This will be 0.305. Let's get rid of that one. And when you look at the fractional part of this, we've got 3/10, 0 hundredths, 5 thousandths. We need to add all those together, or kind of a quick little shortcut is to just take that number there, 305, what we were talking about with our naming. We take all that whole number, and then we just put it over thousands. Right, so this will be 305 thousandths. Okay. Now you wouldn't want to say 305 thousandths. If you said 305 thousandths, someone might think you're talking about this, 305 thousandths. Okay. So I want to make sure you're careful about where you're putting those. All right, 3 more here, and I'm just going to get these put up here rather quickly because I don't think that we need to spend a ton of time on this. So I'll get these answers put up here, and you can kind of see if you have any questions on them. So here's what we got. You're just filling in what you know. You take what you know and fill in everything that you don't. So you can kind of read this, check it out. But that's it. So 8/10, I just put the 8 in here, and then the other zeros, and ultimately that's just 8/10. Okay. All right. The last couple that we have here. So something that you were going to be doing is comparing decimals and figuring out which is larger, and ultimately we're going to do that by we compare the place values of the two numbers as we read them from left to right. Okay, and we've got to compare those place values. So let's go ahead and take the numbers that we have here, and we're going to write them all out. It'll help us to see a little bit easier what we're looking with here. So 3.555 will look like this, and then we have 3. So that's like 3.000. Then we've got 3.055. That's this one here that we just did, in case you lost track. Next we're doing this one, this 3.55, so we'll put this one here. And then of course if we don't have something, you can think about putting the 0 in. Okay. And then we've got this one right here, this 3.5, so this will be 3.5. And then let's do another one about a nice yellow. Probably won't be able to see it much, but we'll figure it out. And so this will be 3.050. Sorry, can't really see that very well. Okay, so if we want to compare these and we want to number these from smallest to largest, when we look here, all the ones those are all the same. So that means we're going to look next over to the tenths place, okay? And we're going to look at the smallest ones in the tenths place. So the smallest one would be, well, here's a 0, here's a 0, here's a 0. So that means we need to be looking at these three right here. And so let's see here. Now, if those are all the same, we got to go to the next one over. 0, 5, 5. Oh, okay. This one is the smallest, right? So I'm only comparing, again, just to be clear, I'm comparing this one, and this one right now because they all had zeros in the tenths place. So that means they're all pretty small. And then we go over one more and we can see, look, this one's got a 0 here in the hundredths place. So this would be 3.000 would be the smallest. Now I'm comparing these other two orange ones that I have. They both have 5s in the hundredths place, so now we're going to go over to the thousandths. And we would see, oh, look, this one has a 0, this one has a 5. This one must be next. So it'd be 3.050. And so now we did this one, we did this one. That leaves us left with this one, 3.055. Okay, so those were the first three. Next, let's go ahead and find the next ones here. So we see that these all have 5s here. So we're going to go over to the next column and look for the 0. This one's smaller. So that must mean that this one is next. This one's the next one, so 3.500. Okay, so that one was a 0. These, the black one and the green one, these both have 5s in them. So let's go over and we'll compare those. Oh, this one has a 0. This one's smaller. So then we'll do 3.550. And then lastly, we have 3.555. So those are the order if we were going to be writing these out. Okay. Now, we don't want to put the actual zeros in the answer though, right? And we can see that none of these have zeros on the back end of the decimal. So you can think about kind of scratching some of these out. Like, so we'll use 3 will be the first, and then we don't need this, so we'll have 3.05. And then that one comes next, nothing to scratch out there, because there's no zeros on the back end. Oh, we got to get rid of both of those. So that'll be 3.5 next. We have a 0 there to get rid of, so that's 3.55, and then nothing there. So this would be the order that I would write my answer down in. Now, when comparing decimals, there's another nice way to do it, and that is to just make sure that we all have the same number of in the denominator, like the same label, if we're all talking about thousandths or 10,000ths or whatever it is, and then just compare the numerators. So if I was looking at something like this, I see how this has 1, 2, 3, 4 decimals. So this one, if I was going to make it so these had 4 decimals, it would look like that. All of a sudden now this becomes 200 10,000ths versus 135 10,000ths, and it's very simple to then just say 200 is bigger. So therefore 0.02 is greater than, let's try that again. 0.02 is greater than 0.0135. So in addition to comparing each number over, each digit over, you can just make sure they have the same number of decimals, and then look at just the decimal as though the number like the decimal isn't even there. They both have 1, 2, 3, 1, 2, 3. They have the same number of decimal places, so therefore we just compare 278 to 203. That's larger. Down here, you might be tempted to say 37 is larger than 13, but look how many decimals we have. 1, 2, 3. This goes out to thousandths. 1, 2. We need another one here. Now we have, we're actually comparing 37 thousandths. We're comparing that to 130 thousandths. So very clearly the 130 is larger. And then the last one here, we've got 1, 2, 3 decimals there, but only 1 there. So this must be 0.100 compared to 0.098. So you can think of this as 100 thousandths and 98 thousandths. Although it's very close, 100 is larger. Okay. The last thing that we're going to look at today is rounding. And you guys should all know already that if the digit to the right of the given place value is less than 5, then all the digits to the right are dropped, right? So for instance, if I want to round this to the nearest hundredth, I would first identify this 2 right here as being the hundredths, tenths, hundredths. And so that's the given place. Then I would look at this 3 right here and I'd say that 3, that's less than 5. And so therefore, because 3 is less than 5, we're going to drop everything after the 2 and we just get 6.92. This is now rounded to the nearest hundredth. Okay, if the digit to the right is greater than 5, you increase the original digit by 1 and then drop all the rest. So if I want to round this to the nearest tenth, I first identify the 3 as being the tenth, and I look past it, and I see, hey, this is larger than 5. It's 5 or larger, I should say. That means that I'm going to increase this 3. I'm going to change this up to be a 4, so this will be 12.4, and then you drop everything afterwards. So it's just 12.4. Okay. All right, let's do these. We've got 5 more problems, and then we're done for the day. I know this got a little bit long. I apologize. So round 0.9375 to the nearest thousandth. Tenths, hundred thousands. That's this one. So I'm going to round to that one, and I look past it, and I see that this 5 right here, that's 5 or larger. So that means that everything is going to round up. I'm going to change the 7 to an 8. This will be 0.93. My board's being silly. 0.938 will be the answer to that one. It's always a good idea to put 0 on the front. I don't always put 0 there, but it's probably good practice to do. Next, we're going to round this to the nearest hundredth. Tenths, hundredths. That's this one. And so the 6 right here is 5 or larger, which means we're going to round that next one up, right? But 9 doesn't really round up. Think of this as like 2.59. We've got to round that up to the next number. So if you're thinking about this as 59 hundredths, we increase it by 1. That will take it to 60 hundredths. Okay? But again, we don't really need that decimal, so we could just write it as 2.6. You can write this as 2.60, and again, that's because of the level of precision that we are working with. We could actually say that here, but it's not super important. Okay. Round this to the nearest whole number. So I look right here. There's my whole number. This number right here is smaller than 5. That means I'm just going to chop it all off. 72. Done. I like the thousandth, 10 hundred thousandth. That's this one. And then I look, I see this is 5 or larger. So this will be 936, and it's 5 or larger. So that means that's got to get rounded up. That 0 right here is going to go up. So it'll be 0.29, and this will change from 0 to 1. So 936.291. The last one then, the nearest hundredth. There's hundredths. This 9 right here, that's too big. Well, I shouldn't say it's too big. It's just it's 5 or larger. So this will be 18.4. We take that 0, we round it up. Done. Okay. I hope this gives you a feeling for how decimals work a little bit. Maybe you already knew all this and this was a waste. I'm sorry. But hopefully it kind of gives you a picture of just how decimals work. And we'll be working a lot more with add, subtract, multiply, divide in the future. All right, good luck with everything you're doing here.